So we're on page 325 in your workbooks, and we're looking today at completing the square. And the purpose of completing the square is to allow us to go from the general form of our quadratic function, so y equals ax squared plus bx plus c, and convert that into, or express that as vertex form or standard form. And of course we like the vertex form because it gives us a lot of information very quickly. We can clearly see what the vertex is, the equation for the axis of symmetry, the minimum or the maximum value, and lots of other good stuff. So let's go back and just review perfect squares and how to square a binomial. So x plus 4 all squared, x minus 5 all squared are examples of perfect squares. And so if we want to expand them, then we can write them out. X plus 4 all squared, of course, is x plus 4 times x plus 4. And that reminds us that we do have a middle term. You cannot simply square x and square 4 because there is that middle term when we distribute through. So we should be looking at x squared and then plus 4x, which is actually plus 8x, and then 4 times 4 is 16. So take a moment, hit pause, and complete the other 5 questions and come back and check your answers. So when we take a look then, we've got our expanded form of these binomials that have been squared, of these perfect squares. And so going through them, what we want to do is we want to be able to go through them a little bit more quickly. So we're recognizing then that obviously x squared comes from x plus 7 squared. So that x squared is obviously then the x term that is squared. The 49, that of course is never an issue either. That is the last term, so 7 squared. So the 14x comes from our 7x and our 7x. And because they're the same, notice how we can also see 7x by looking at the original perfect square. So 7 times x, and then because if there are 2 of them, then it's 14x. So this 14x essentially comes from then x and 7 times 2. Okay, so that's why we've got here, obvious here hopefully for your x squared and your a squared, but for your minus 2ax, we've got x times negative a, which is negative ax, times 2 gives us then negative 2ax. Okay, so let's take a moment then and factor these expressions. So we've got then x squared plus 6x plus 9, so then it's going to be x plus, and to figure out that last term, we can take the square root of 9. As well, we can also divide 6 by 2, positive 6 by 2. So, and this is x plus 3 all squared. So we're thinking about what is the square root of 9. We're also thinking about what is positive 6 divided by 2. And that gives us positive 3. Then, so same thing here, I'm looking at the square root of 4, but I'm also looking at negative 4 divided by 2, so that gives us then negative 2 is going to be that second term in our binomial, so x minus 2 all squared. So finishing up the other 2, again hit pause and complete and come back. Okay, so if we take the square root of 36, we get 6 as well. If I divide positive 12 divided by 2, I also get positive 6. Again, negative 16 divided by 2 is negative 8, and if we square negative 8, I get 64, or I can take the square root of 64. So looking into part C, now we're actually moving into completing the square. So we're trying to figure out what that third term is going to be so that I have a perfect square. So remembering that in order to come up with that second term, I know I'm starting with x here, so to come up with this second term, I can go through 2 ways. I could have taken the c value here and taken the square root, but that c value is missing, in which case I can I just have to take this 2 and divide it by 2. So if I take 2 and divide by 2, that is of course 1, so that gives me this as positive 1. If I want to find that c term, then I'm going to square that 1. So 2 divided by 2 squared obviously gives me 1, and that fills in here, so we're x plus 1 all squared. Let's move over to the right here. So if I've got x squared plus 18x, again, to fill in that c term, I can take 18, divide it by 2. That will fill in what the second term is going to be, but to find my c term, I need to square that. So 18 divided by 2 is 9, squared is 81. And so then that tells me that it will be x plus, well, square root of 81, as well as 18 divided by 2 is 9, and that is x plus 9 all squared. So a little bit more confusing when we've got an odd number, it doesn't divide evenly. Ideally, keep it in fractions because that'll allow you to do more operations easily without your calculator. And we're also dealing with exact values easily and quickly here too. So again, to find this c value, here, what do we want? -3. We're going to take that b value and divide by 2 and square it. So squaring means multiplying it by itself. So -3 times -3 is 9. Then 2 times 2 is 4. So we've got then 9/4 will be my c value. And then to factor it, it will be x minus, and we can divide -3 by 2, which is -3/2, and of course that is also the square root of 9/4. So that's x minus 3/2 all squared. Again, so now we want to take -1/4 and, -1/4 and divide by 2, but I don't really want to do a complex fraction. So dividing by 2 is the same as multiplying by 1/2. So of course I'm going to divide by 2 and square it. So let's write the proper notation. We've got everything together. So -1/4 divided by 2 is the same as multiplying by 1/2 and squaring. So then that is -1/8 all squared, which is going to give us positive 1/64. So that is my c term, and then to factor it, I will have x and -1/4 divided by 2, or multiplied by 1/2 is -1/8. That, of course, is the same as 1/64 square root. So x minus 1/8 all squared. So let's take a look then at some examples. Okay, so if I've got x squared plus 10x plus 16, so y is equal to x squared plus 10x plus 16. So what we want to do is just kind of like our last exercise there, is to complete the square. So we've got y is equal to x squared plus 10x, and I'm going to leave a big blank and have plus 16. So because I want the values, of course, to stay the same, the functions to stay exactly the same, so I can't drop that plus 16. So we have to think to ourselves, what is the number that is going to fit in here to complete the square? So how do we find that value again? Well, I need to take 10, divide it by 2, and then if we square it, we end up with 25. So positive 25 will complete the square, but now my function no longer looks the same. X squared plus 10x plus 25 plus 16 is definitely not the same as x squared plus 10x plus 16. So if I'm adding 25, I also have to subtract 25, so then that is the same as just adding 0, which doesn't change the function. But now I have my perfect square trinomial, and I can factor that, so I've got then y is equal to x plus 5 all squared, and then the remaining piece is -25 plus 16. If we clean that up, it's simply minus 9. So if we graph both y equals x squared plus 10x plus 16 and y equals x plus 5 all squared minus 9, they should look identical. So why don't we open up our graphing calculators and enter those in and take a look. So I have my two equations, my two functions entered into the calculator. Under y1, I have my general form. and under y2 we have the vertex form. So hopefully when we hit graph, they should come out as identical. So there is our general form, x squared plus 10x plus 16, and then the second graph in vertex form goes right on top of it. So that gives us confirmation that these two represent exactly the same function. Excellent. So moving on then, we've got a similar question. So f of x, let's keep that in function form, is equal to x squared minus 9x and minus 20. So to complete that square, then I need x squared minus 9x. I'm going to leave a blank for completing the square as well as taking out whatever I've added, and we'll leave that minus 20 off to the side. So again, what do I add on to complete the square? So on the side, I'm thinking to myself, negative 9 divided by 2, and then square it. That will give us our c value. And so since that doesn't divide nicely, we're just going to keep that in fraction form. And so when we square it, then it is equal to 81 over 4. So we'll add 81 over 4 because we add it. We're also going to subtract that. So now that we have our perfect square, 81 quarters, we can factor that. So then we have f of x equal to x minus, and then we can either take the square root of 81 quarters, or we can take negative 9 divided by 2. That's probably the easiest way, squared. And then we've got to clean up the back end of things, which is minus 81 over 4. And of course, we need a common denominator, so then that would, negative 20 is the same as negative 80 over 4. So f of x is equal to x minus 9 halves all squared minus 161 quarters. And no need to change that into a decimal or a mixed number. So there we have our standard or our vertex form. And because we have our vertex form, when we go back to the question, it is asking us for the minimum value. So the minimum value is, of course, our q value. So the minimum is equal to negative 161 over 4. So if we take a look now, it gets a little bit more complicated because we now have a coefficient in front of our x squared. So we have f of x is equal to 3x squared minus 18x plus 20. And so there's two things that we should be considering. Number one, remember the form that we're trying to get to, our vertex form, is y is equal to a times x minus p all squared plus q. So the coefficient as it is has to be out front. Has to be factored out to begin with. And secondly, it's a lot easier to come up with our perfect square when we have a coefficient of 1. So let's start by factoring out that 3. So then we would have f of x is equal to 3 times x squared minus 6x. And again, because that 20 is going to be part of my q value, I'm not going to put that, I'm not going to keep that in brackets. I don't need to factor the 3 out. So then at this point, we want to complete this square. So we have then f of x is equal to 3 times, and we'll have x squared minus 6x. And to complete that square, we need to take that b value of negative 6 divided by 2 and square it. So negative 6 divided by 2 is negative 3. Squared is 9. So 9 will complete the square, but it has previously done, if we're adding 9, then we also need to take away the 9. And then we are adding the 20 on. So from here, then we have our perfect square. But the problem is we've also got this negative 9 in the bracket as well. So we need to kick the negative 9 outside of the bracket, but in order to do so, we have to apply a factor of 3 to get that out of the bracket. So we'll have then f of x is equal to 3 times x squared minus 6x plus 9, and to get that negative 9 out, it will now become negative 27. We've multiplied it by 3 and plus 20. So now let's just clean things up. We've got f of x is equal to 3 times, and we'll factor this, so it becomes x minus 3 all squared, and then negative 27 plus 20 is minus 7. So there is our vertex or standard form, and again, it's looking for a maximum or minimum value. Because we can see that a is positive 3, it opens up. That means we have a minimum value. That minimum value is our q value, which is negative 7. Let's take a look at class example number 4. So this is just written in ascending order instead of descending order. So we'll start by rewriting it in descending order. So negative 2x squared plus 10x plus 7, and then we know we need to factor out the negative 2. So y is equal to negative 2 times x squared, and because I'm factoring out negative 2, this is now negative 5x. We want to now complete the square. So again, what are we doing? We're taking that b value of negative 5, we're going to divide by 2, and we will square that. And so keeping it in fraction form, negative 5 over 2 times negative 5 over 2 is 25 over 4. So we add 25 quarters. We will then also subtract 25 quarters, and then that positive 7 stays outside. So now we have y is equal to negative 2 times x squared minus 5x plus 25 over 4. In order to kick out the negative 25 quarters outside of brackets, then we need to multiply it by negative 2. So we're just over to the side here. We can multiply negative 2, or negative 2 over 1 times negative 25 over 4. So that ends up being positive 50 over 4. Reduced is 25 over 2. So then this is now plus 25 over 2 plus 7, but because I'm going to be needing a common denominator, that will be 14 over 2. So cleaning everything up, we've got y is equal to negative 2 times x minus 5 over 2, so the square root of 25 over 4, or negative 5 divided by 2 squared. Combining these two for our q value, we have plus 39 over 2. So there's our standard vertex form. And so when it asks for the coordinates of the vertex, coordinates for a vertex PQ are then 5 halves and 39 halves. Excellent. Let's move on to the next example then. So for class example number 5, it's asking us to put it into completed square form, also known as vertex form or standard form, and then use the form to determine the zeros of the function. So I'm not sure whether they're asking to the nearest hundredth, because if you're asking to the nearest hundredth, then that assumes that you could use your calculator, in which case I would probably just enter in the general form to find the zeros and use my calculator. But let's go through and we'll also figure out the exact values then. So looking at completing the square then, we've got f of x, and we want to start by factoring out the 3 again. So we've got x squared minus 4x, and then to complete that square, we're going to divide negative 4 divided by 2 and then square that, so then that is negative 2 all squared, so it's plus 4, and then I need to also subtract 4, and that negative 8 is waiting patiently outside. Then we have 3 times, and our perfect square is right here, so that is x minus 2 all squared. When we kick the negative 4 outside of the brackets, it's multiplied by our a value, which is 3, which is now negative 12 minus 8. So then we have 3 times x minus 2 all squared minus 20, and that is our function f of x in completed square form or vertex form. So if we want to find, work out well, if we want to find the x-intercepts then and look at the exact value, so the x-intercept, of course, y is equal to 0, so that means that f of x is 0, so 0 is equal to 3 times x minus 2 squared minus 20, so we'll start by adding 20 to each side. So of 20 is equal to 3 times x minus 2 all squared. We'll then divide both sides by 3. So then we now have 20 over 3 is equal to x minus 2 all squared. Then we take the square root of each side. So we take the square root of 20 over 3, and remember that now becomes plus or minus 20 over 3. So that helps ensure that we have two x-intercepts, or 2 zeros, and that's equal to x minus 2. So to finish things off, we have 2 more steps to do. First off, we recognize that the square root of 20 can be simplified. Okay, so, but if we add 2 to both sides, I end up with 2 plus or minus root 20 over 3 is equal to x. And so I could enter that into my calculator. 2 plus root 20 over 3 is one x-intercept. 2 minus root 20 over 3 would be the other x-intercept. If I want the exact values, then I need to simplify root 20, and root 20 is the same as root 4 times root 5, so that's looking at 2 root 5 then. So we would have 2 plus or minus 2 root 5 over root 3 is equal to x, but then that needs to be rationalized, in which case I need to multiply top and bottom by root 3. So then we've got 2 plus or minus 2 root 15 over 3 is equal to x. So I would be fine at this point if you left it as x is equal to 2 plus 2 root 15 over 3 and 2 minus 2 root 15, and that is over 3. Okay, excellent. And so please complete the questions that have been assigned, and let me know if you have questions.